Hi everyone, today we're going to look at atomic structure and revision of that area. So specification points are shown here in the bottom left hand side of the sheet. So basically we're going to cover most of these specification points through completing this sheet. So let's start off with this on the top left hand side. So it says use the diagrams below to record how models of atoms have changed over time. So Dalton had an idea about particles. Okay, so he called them particles or atoms, and they were solid. So like circles, like we would have drawn at key stage 3. That was in 1803. Then moved up more recently, Thomson introduced the idea of a plum pudding model because he had discovered electrons. And he thought that these electrons are dotted throughout the atom. Rutherford then went on to do some experiments, and he discovered that actually there was a very tiny nucleus that was positively charged at the centre of the atom using his gold foil experiment. So positive charge or positive nucleus at the centre. So it's quite different from this plum pudding model when you've got dots throughout. There's a nucleus in the centre, but he found out that it's very, very tiny. And then more recently, this is the accepted model now, Bohr's model. So you have a nucleus, which contains protons and neutrons. And you have electrons orbiting, which are those crosses on the outside. Okay, so let's move on to this section here. So looking at those subatomic particles that Bohr were talking about, you've got protons, neutrons and electrons. So what are their relative masses? Relative mass, so proton is equal to an electron. Okay, and proton is equal to the neutron. And then we have the electron, which has a negligible mass, 1 over 1,835, okay, or 0. Relative charge then, so the charge in comparison to each other, proton is a positive, neutron is neutral, electron negative. Just be careful in an exam that you read, if you're filling in a table that looks like this, you read really carefully whether they're talking about the mass or the charge, because some of these, they try and catch you out. Okay, using the information above, explain how atoms have no overall charge. So that is because the number of protons, which are positive, are equal to the number of electrons, which are -1. So if you have 5 pluses and 5 minuses, they equal out. So there's no overall charge. Let's move over here. So label this atom using the keywords nucleus, proton, neutron, electron shell. So this bit in the centre here, that is the nucleus. This is what Rutherford discovered. There's a tiny nucleus, so this is not to scale at all. There's a tiny nucleus in the centre of every atom, which has an overall positive charge. And the reason it has an overall positive charge is because of the presence of protons. I'm going to label these kind of orangey ones protons for now, but it doesn't really matter. Okay, and that one is neutron, so that has no charge. Okay, so therefore that's why the nucleus is positive overall, because you've got your pluses there, and then no charge with that. We've got these electrons around the outside, and this is the electron shell. Okay, what is the mass number of this atom? So mass, I'm going to use my highlighter here to help me. It's always useful. So mass. Okay, that's a very important word. If I look back to my previous, oh dear, knocked my camera there, sorry. If I look back to my previous information here, the mass is in the protons and neutrons. You can see electrons don't really weigh anything. So if we're talking about the mass number, we're talking about protons and neutrons that each weigh the same amount of each other with a relative mass of 1. So if we look at this, we've got 1, 2, 3, 4. So the mass number must be 4, okay, because the mass is found in the nucleus. It's the number of protons plus neutrons, and in this case it's 2 plus 2 equals 4. Okay, what is the atomic number? Okay, that's slightly different. The atomic number is unique for every atom. If you increase or decrease the atomic number, you change the atom that you have, you change the elements. The atomic number is really important. It's actually the number of protons. So if we look back here, if we count the protons, this orangey colour, we've got 1, 2. So the atomic number must be 2. It is the number of protons. Like I said, that is unique to every single atom of each element. Okay, it is also equal to the number of electrons in the atom of that element. Okay, let's move on to the left. What is an isotope? How does this impact mass number? So an isotope is an atom of an element with a different number of neutrons. So this will change the mass. Because if you look previously, we said the neutrons have a mass that are equal to protons, so relatively large in comparison to electrons. So if you increase or decrease the number of neutrons, it will increase or decrease the overall mass. The last section then. State as many facts as you can about beryllium using the periodic table to help you. Okay, so I'm going to get my periodic table out. So it's over here. I'm going to find beryllium. It is here. So it's got a 9 and a 4. So I'm just going to write it in here. Quite big. Be, the 9 and 4. Okay, and I'm going to look and I'm see. Oh, look, it's in group 2. So I can just see it above here. It's in group 2. So I'm going to just write it is in group 2. Okay, so now we're looking at this. This one at the bottom, this smaller number, is the atomic number, which equals the number of protons. So in this case, it is 4. This also equals the number of electrons. That is 4 as well. Okay, so then I'm going to look at this one here. So that's number 9. So this is the mass number, which equals the number of protons plus neutrons. And that's in the nucleus. Oh, just moving over. So in the nucleus. So in this case, the mass number is 9. And if we know the number of protons is 4, so 4 plus something equals 9. So therefore the number of neutrons must equal 5, because 5 plus 4 equals 9. So we've got that there. So we've got, if I highlight it, protons is 4. Electrons is 4, neutrons is 5. It's in group number 2. If I look at that, group number 2 means it has 2 electrons in the outer shell. So 2 electrons in the outer shell. So I'll have the electronic configuration 2.2, because 2 add 2 is 4. So I'll just put that in brackets, electronic configuration. Okay, and I'm going to look again at my periodic table here. That's on the left-hand side here. It's a bit fuzzy, I'm afraid. I hope it'll go into focus soon. So it's on the left-hand side. That means it's a metal. The ones on the right-hand side are non-metal. So it is a metal. Brilliant. So that finishes off this section. I'm just going to highlight those key points there. So it's a metal because on the left-hand side it has 2 electrons in the outer shell and electronic configuration of 2.2. Okay, so there we go. Thank you very much.